Welcome to the first math reviews lecture, and today we'll be doing basic arithmetic review. Alright, so let's get started. First, we'll talk about numbers, a very basic mathematical property. So there are three types of numbers that you can possibly have, three broad categories. So one is positive numbers, you could have a 0, or you could have negative numbers. Okay, pretty simple enough. Now you can, if you take a number line, the way these three types of numbers show up here is that first you have kind of in the middle the 0, and then going to the right of 0 you have 1. You have the positive numbers 1, 2, 3, 4. So going to the right of 0 you have the positive number. So this is a shorthand plus VE, shorthand for positive numbers. And then if you go towards the left you have the negative numbers. Okay. Alright. One thing that you'll see in GREs are what you call these absolute numbers, or absolute value to be precise. So what is that? What that means is basically you have, let's say you have your negative number 3, right? And you'll see sometimes on GRE that the number is surrounded by these two straight vertical lines. Okay, so what it means, or the way this is said, is the absolute value of -3. Okay, so what this simply means is that whatever you have inside these two vertical bars, whether it's a negative number, positive number, the vertical bars, what they do is they do a kind of a, they apply this process where they make it positive. So whatever's in there, when you have these bars around it, the end result is that you get a positive number out of it. So the absolute values are always positive. Okay. Another example, let's take -10. So I'm trying to find absolute value of -10. So this again would be 10. Alright, what about if I want to take an absolute value of a positive number? So in this case, let's say absolute value of 4. Well, 4 is already positive, so well, you just get 4. That's the answer. Okay. So later on you'll see more complicated problems with absolute values, which would be pretty good practice for the GREs. Alright. Next topic is operations. Operations with numbers. So the simplest one that we all have seen is addition, subtraction, right? So what it means is that you can add two numbers with this plus sign in the middle. 2 plus 3 is 5. You can subtract. 2 minus 3 is -1. Okay, simple elementary stuff. Next, you could have multiplication. So again, pretty elementary. Let's say we have 3 times 6 equals 18. Now just in GRE terms, sometimes you'll see basically this thing said in words like this. So product of 3 and 6 is 18. So when you see this word product, it just means that you're multiplying two numbers together and the result is, in this case, 18. Okay, let's look at division now. Okay. Division is when you divide one number by the other. So let's say, well, we take 18, we divide 18 by 6 and you get 3. Now GRE would write this in words this way: quotient of 18 and 6 is 3. Okay, so this number is known as the quotient of your division process. So this is very important. You'll see this word a lot, and it will be very good to know this terminology. Alright, so that's enough for the operations. Next is, let's look at the number 0, which has some interesting properties. So we all know that first, if we multiply a number by 0, so let's say 0 times a can be any number you pick. So it could be any positive, negative, or even 0. Okay. So you multiply any number by 0, what do you get? You get 0. Okay. You divide 0 by any number, that gives you 0. If you divide a number by 0, well, this is not defined. So you can't, if you plug this in the calculator will not give you an answer. So you can't solve for this. Okay. Third is an interesting property. Let's say product of two numbers. Let's say the two numbers are a and b. The product of these two numbers is 0. This implies that either one, at least one of these is 0. So either a is 0 or b is 0. Right? So this comes back to this property that 0 multiplying by any number will give you 0. So if you have product of two numbers to be 0, at least one of them has to be 0. Okay? Both of them can be 0 too, but for sure one of them has to be 0. Okay? Alright, so let's do a quick problem on number properties. Okay? And actually specifically this is the properties of 0. So we'll do this problem. Right? So these are those quantitative comparison questions where you have two quantities in column A and B. So make sure you know what the rules are when you're picking choices in these type of questions. So quantity A, we have the product of the integers from -7 to 2. Okay, we'll tell you a bit later what integers are, but just think about them as numbers. So as whole numbers. So we are talking about taking the product of -7 times 4 times 3, and so so you're thinking of taking the product of -7, then -6, then -5, so on till 2. So you'll pass 0, and then you'll pass 1 and 2. And here we are looking at doing the same, but starting from -2 and ending at 7. So see in both cases you'll pass 0, and all your numbers are in there, and then you will have 0 and so forth. So again, going back to that property where if you have 0 multiplying by other numbers, the result is always 0. Okay, so in both cases you'll get 0 on column A and column B. So the correct answer is C in this case. Okay. So see how we didn't have to actually calculate the product, because there was 0 in there, and that helped us determine the product without the use of a calculator. Alright. Okay. Next, let's look into the multiplication process more, or as GRE calls it, the products. Okay, so it's interesting to see how the signs come into play, positive or negative sign, when you are doing multiplication. So let's say you have -3 times -4. So 3 times 4 is 12, but now you have these negative signs in front of the number. So actually what happens is that when you have a negative multiplying with a negative, it ends up being positive. Okay, so to write in other ways, if you have a negative times a negative, a product of two negative numbers, you always get a positive. Okay, what about if you have one negative and the other positive? Well, the absolute value is still 12, but in this case, when you have a negative times a positive, you actually get negative. So representing here, if you have a negative times a positive, you get a negative. That's the answer, always. Okay. Similarly, if I switch the signs of the negative, so for the first number I make positive and the second number I negative, the result is the same. I still get negative 12. So if I switch the signs here, I still get a negative. And lastly, if I have both numbers are positive, well, I just get a positive answer. So if both are positive, then I get a positive value. Okay. So very elementary rules. So these set of rules also apply to the division process. Okay, so let's say if I have 12, negative 12 divided by negative 3. So I know 12 divided by 3 is 4. And negative, just like in product gives you positive, here it will also give you a positive 4. Okay. What if you have, let's say, more than two numbers? So let's say you have negative 3 times 4 times negative 5. Well, as far as the value is concerned, the absolute value is concerned, I'll have 3 times 4 is 12, 12 times 5 is 60. And what about the sign? So the way to do sign is do them like, you know, 2 at a time. So negative times a positive will give you negative, and then I have a negative here and a negative here, which will give me a positive. So in the end, my answer will be positive 60. Again, you have a negative here, you have a positive here, you have a negative here. Do these two first, you get a negative. Do these two, you get the positive. Alright? Okay. Next thing is reciprocals, which is again a very simple property. So let's say you have a number a, then 1 over a is its reciprocal. If I have 3, then its reciprocal would be 1 over 3. If I have, let's say, 1 over 5, its reciprocal would be 5. So whatever you have, you just flip it. Okay, so here you had 1 over 5, so you flipped it. It's actually 5 over 1, but we just write it as 5 because 1 is the term, doesn't matter. Here, in a way, we had 3 over 1. So we flip it, we get 1 over 3. So that's what's basically the reciprocal process. You just flip the number. Okay. Another property that would be good to know is, let's say if you have fraction like this a over b, I can write it as a times 1 over b. Okay, or I can also write it like a times 1 over b like this. Okay, all are equivalent statement. All say the same thing. Next, we'll look at types of numbers that we can have. Alright, so the first category of numbers that you need to know are integers. Okay, integers are numbers that look like whole numbers. So like if we go again back to our number line, let's start with 0. So you can have 0, 1, 2, 3, 4, and so on. So these are all 1 and above are all positive integers. And on the left, you'll have negative 1, negative 2, negative 3, negative 4, and so on. So these are your negative integers. And just to keep in mind, 0 is also an integer. Okay. Another terminology that you'll see in GRE is, oops, the pen is not working properly. Not sure why. Okay, the another category you'll see is consecutive integers. Okay. So consecutive integers are any number of integers that are next to each other on the number line. So like over here, I would say 1, 2, 3 are 3 consecutive integers. So 1, 2, 3 are 3 consecutive integers. Similarly, if I have -4, -3, -2, these are again 3 consecutive integers, but on the negative side of things. Alright. The next category of numbers that we need to know are the even odd numbers. So this you might again remember from your high school math class. Even numbers are, which ones? They are like 2, 4, 6, 8. So anything that's completely divisible by 2, or it actually is a product where 2 is involved. Also to remember is that 0 is an even number too. Okay, this continues on. One more thing to remember is that you can have negative even numbers too. So numbers like -6, -4, -2. So if I put everything in there, these are all your even numbers, and it continues on both sides. Okay, similarly you have your odd numbers. So any integer that's not even is odd because it's not divisible by 3. So your odd numbers are -5, -3, -1, 1, 3, 5, 1, 3, 5, and so on. Okay, this is -1. Okay. So again, just to remember, even and odd, they are all integers. They cannot be non-integer numbers. So what are actually non-integer numbers? So what are the other types of numbers? So you can have numbers with decimals, like one number with a 1 decimal place after the decimal. You can have numbers which go on and on, they don't stop anywhere after the decimals, like 1.2, 3, 4, 9, 8, and they keep going on. Other numbers, like some of the, like pi is one of those famous numbers, is 3.14, and then it continues on and on. Okay. Alright, so let's try some examples. Alright, so how about we do this one? So if 2 is less than x is less than 4, so these symbols are for less than something. So when you say 2 with the symbol x, it means 2 is less than x, and x is also less than 4. And 3 is less than y is less than 7. What is the largest integer value of x plus y? So see this integer value. So what you're looking for is an integer to be an answer. Okay, no decimals here. So x can only be between 2 and 4. So the only integer between 2 and 4 is actually 3. And then for this you have y is greater than 3 but less than 7. So here your integers that you have are 4, 5, 6. Okay, now if I take 3 and 6, because I want the largest value, I'll get 3 plus 6 is 9. But is that the correct answer? Actually it is not, because you only want the answer to be an integer, but the numbers, the x and y values, can be non-integers. So what if you pick, let's say, 3.9 for x, which satisfies this condition that x has to be between 2 and 4, and what if you pick y equals, let's say, 6.9, which satisfies this condition for y to be between 3 and 7. So if you take these two, actually you get 10. And you can check further that they are, well, actually, sorry, So the y has to be 6.1. So you'll see in 3.9, 6.1 will give you 2, and 10 is the largest integer value that you can have with these that satisfies these two conditions for x and y. Okay. So again, it's kind of a tricky question, because one would think that okay, pick 3 and 6 to the two integers and get 9, but your x and y can be non-integers. Only the sum has to be an integer, right? Okay, let's do one more. How many positive integers less than 100? Positive integers. So positive integers are 1, 2, 3, 4, 5, 6 onwards. Less than 100 have a remainder of 3 when divided by 7. Okay, so first, before we go into the problem, let's make sure everyone understands what remainder is. So if I divide, let's say 10 by 7, okay, what I'll get is 1 point something, right? 1 point actually 4 and whatever comes after that. So 10 is not completely divisible by 7. I know 7 times 1 is 7, okay, and 7 times 2 is 14. So 10 is between these two multiples of 7, right? So in this division, what I say is that my quotient is 1 and my remainder, so remainder is when something does not divide completely, what's left is called remainder. So remainder here is actually 10 minus the last multiple before 10, which is 7, 3. Okay, so this is the definition of 3. When you divide something by something, whatever is left over after you take out the quotient part of it is called the remainder. Okay, so they are asking that you take positive integers that are less than 100, divide that by 7, and tell me how many of those, when after division, will have a remainder of 3. Okay, so just like over here, in the example we just did, we took 10, we divided by 7, and we know this gives a remainder of 3. So you want to find all these numbers like 10, less than 100, positive integers less than 100, that will give us a remainder of 3. Okay, so let's start. So 10 we know will give us that, and the easiest way is basically to add 7 to get the next number that will give a remainder of 3. Again, add 7, 24. This will keep going on till, so you'll pass 73, then you will also have 80, 87, 94. So if you count all these numbers here till here, you'll have 10. Okay, because 7 times 1 is 7, and this is the one coming after that first one. So you'll have 10 here, and then 11, 12, 13. Okay, 3 these ones, and actually there's one more. So if you look before this, what if I take 3? So 3 when divided by 7 will also give me a remainder of 3. Okay, so in all I have 10, 11, and 3, 14. So they have 14 positive integers that give a remainder of 3 when divided by 7. Okay, so the next topic is factors and multiples. Okay, so let's start with factors. You might have seen a statement like this: 3 is a factor of 12. So in very simple terms, what it means is that 3 multiplied by some number can give you 12. Okay, so we know 3 times 4 gives us 12. So both actually 3 and 4 are factors of 12. Okay, so in very simple terms, factors of a number are numbers that when multiplied by something give that number. Okay, in other words, I know that 12 divided by 3 is 4. Okay, so this is a complete division, so it means 3 is the factor of 12. one more way to say is that the 12 comes in the table of 3. Okay? So, alright. Next is multiples, which is similar, which builds on the factor terminology. So, for multiples, you might have seen a statement like this: 12 is a multiple of 3. Okay, so it's inverse of the factor statement, right? Again, we know 3 times 4 is 12. So in a way, a multiple of 3 is something that comes in the table of 3. So we know 3 times 4 gives you 12. So 3 is the multiple of 12. But 12 is a multiple of 3. Similarly, 12 is a multiple of 4 also, because it comes in the table of 4 too. Okay, be straightforward. Let's look at an example to get this concept pretty cleared up. How about we pick the number 6? Okay, so let's write all the factors of 6. Okay, so these are all the numbers which when multiplied by some other number will give you 6. So like, I know 1 times 6 will give me 6, so 1 is a multiple. 2 times 3 will give me 6. 3 times 2 will give me 6, so 3 is a multiple. Is 4 a multiple? No, because 4 times I don't know what will give me 6. So 4 is not a multiple, and the biggest multiple we'll have is 6. Similarly, we can have the negative ones, so all these on the negative side will also be multiples, right? Will be factors, sorry. And then let's look at multiples of 6. So multiple of 6 are everything which might appear in a product of 6. So like, I know that 6 times 2 is 12, so 12 is a multiple of 6. 6 times 1 is 6, so 6 is a multiple of 6, and so on. I will have 24, I will have 18 also, 24, then 30, then 36. On the left side, actually, I'll have 0. 0 is also a multiple, right? Because 0 times 6 is 0. And then I'll have the negative ones similarly. So multiples can be many, actually infinite, right? But factors are a few. Okay, moving on. Next we have prime numbers. So these are very special numbers, and their definition goes like this. So numbers that are only divisible by 1 and itself. Or in other words, numbers that only have 2 factors. Okay. So let's look at an example. So let's say if I pick 3. Okay. So the factors of 3 are only 1 and 3, because these are the only numbers. These are the only things that will divide 3 completely, right? So this is actually a prime number. Similarly, what about 2? Again, the only 2 factors for 2 are 1 and 2, so it again is a prime number. What about 4? Well, for 4, the factors are actually 1, 2, and 4. Well, there are 3, so this is not a prime number. So starting actually, there's this list of prime numbers that we need to memorize, and it's very important. So 2, 3, 5, 7, then 11, 13, 17, 19, 23, 29. So this list of prime numbers you need to memorize. This is very important. If especially the first few ones, that's what you have to memorize. And the other thing you need to know is that 1 is not a prime number. Okay, so this is just by definition. Okay, so memorize this. Okay, moving on. There's this concept of a factor tree. So sometimes you get these big numbers. So let's say you have 108 and you want to find all of its factors. So one way to do is to make this factor tree. So, and it's always good to start with 2 if you have an even number, with 2 being one of the factors. So 2 times 54 will give me 108, right? And since 2 is a prime, I'm going to circle it because I cannot further divide 2. 54 is actually not a prime, it's an even number. So it will further divide, and again, since it's even, I can put a 2, and the other number here would be 27. 27 times 2 is 54. 2 is again a prime. 27 can be further divided into, in this time I have an odd number, so I cannot use 2, so let's use 3. 3 times 9. 3 is a prime, so I can stop there. And for 9, I can have 3 and 3, right? Okay, so this is what's known as a factor tree. Basically, what it tells you is that if I take all the primes and give a product of that, 2 times 2 times 3 times 3 times 3, this will actually give me 108. Okay, so if you take the prime factors of a number, all the prime factors, not only the unique ones but everything, then the product will give you the actual number. And other numbers like 1, 9, 1 is always a factor. 1, 9, 27, 54, 108 are other factors of 108. Okay. Alright, let's do a GRE problem on factors. So here's our factor problem. Okay, this one. For any positive integer a, let a denote the smallest prime factor of a. Which of the following is equal to 35? So this is a very typical GRE problem where they define something. Here they define this bracket a to be the smallest prime factor of a. So they define something and they ask you to use that definition to find something else. So here they want us to find 35. And what this represents is the smallest prime factor of 35. So let's find all the factors of 35. Okay. So again, if I go and make a tree, I'll get 35 is 3 times, oh, not 3, it doesn't go 3. It's 5 times 7, okay? And both 5 and 7 are prime, right? So actually, this parentheses 35 is equal to 5, which is the smallest prime factor, okay? Now you need to find, out of all these answer choices, which one will also give you 5, okay? So let's do it here. For 10, the factors are 2 and 5. So here the smallest prime factor is 2, so 10 cannot be your answer. Okay. For 15 is 3 and 5. Again, the smallest prime is 3, so 15 cannot be your answer. For 45, you'll have 9 and 5, and 9 will further divide into 3 and 3. So you get 3, which is again smaller than 5, so you can't get that. For 55, oops, let's write it without the brackets. 55 will have 5, 11, okay, and both of these are prime, and here, there you go, 5 is the smallest prime factor for 55, so 55 is your answer. Okay, so 55. We can also do it for 75, just if you're curious. I'll have 5 and 5 times 15 is 75, and 15 is 3 and 5, so here is 3 is the smallest prime factor, so 75 cannot be that. But actually, just a GRE hint, a good test taking thing, in a multiple choice question, when you're sure something is the right answer, then just go with that. Don't go and check the next answer choice, but only when you're confident. So if you're confident D is the right choice, don't even look at E. Okay. Alright, so next topic is exponent and roots. So you probably have seen this a lot, you know. You have a number and on top you have another number, right? 4 squared. And we know we call this 4 squared and this is 16, right? What this basically means is that you have 4 times 4 and that's 16, right? Now this is GRE terminology again that you need to know. So for this 4 squared, this 2 is known as an exponent. Also known as power. Okay, and 4 is called the base. Right? So for these exponents, there are some rules. So let's go through these rules. Okay. Rule number 1. Let's say you have a number raised to a power m, and that same number then raised to power n. So you have product of these two numbers, right? They have the same base. So in this case, what you can write is basically the same base raised to a sum of these two powers. Okay. Another way to remember this is that same bases, when bases are same, powers are added. Okay, let's look at another example, another of the rules. Let's say you have, instead of a product, you have a division. Okay, in this case, you can bring the denominator to the top and write it like this: b raised to m minus n. Okay, so you just subtract the powers. And the rule is when you have a number raised to a power, and then that thing is again raised to a power. So this can be written as the product of these two powers, so m times n. So b raised to m times n. Right. Fourth rule is like this. So if you have a product raised to a common power, so b times c, everything raised to m, then you can distribute the power individually to the numbers. Like this. Okay. Similarly, if you have a division, b over c raised to m, this is parentheses, brackets, then you can write it as b raised to m over c raised to m. Okay, as a quick example, let's say we have 2 raised to 2 times 2 raised to 3. So applying the first row, we'll have 2 raised to 2 plus 3, and this would be 2 raised to 5, which is 32. Alright, let's do a GRE problem about this. So here's our GRE problem. Okay, so we have sorry about that. If 2 raised to x equals 32, what is x squared? So this is a very typical GRE problem. If 2 raised to x is equals to 32 and you want to find x squared, so first you have to find x. So in these type of problems, you always want to write the other number with the same base. Okay, so here your base is 2, you want to write 32 in a way that's base is 2. So what you would eventually come to know is that 2 times 2 times 2 times 2 times 2 is 32. So this is 5 2's, 2 raised to 5. Okay, so instead of 32, I can write 2 raised to x is equal to 2 raised to 5. Okay, so now once you have the bases the same, then the powers also have to equal. So x has to equal 5. Okay, and since they are asking for x squared, 5 squared is 25, so C is the right answer. Okay. Right. A couple of other rules on exponents. Okay, and especially involving zeros. So 0 and exponents. Okay. So 0 raised to any number. 0 raised to any number is always 0. Okay. Secondly, 1. If I have any number that's raised to 0, this is always 1. Okay. And b can be anything, positive, negative, 0, whatever. So if you have 0 as a power, that's always 1. Another interesting property to know for exponents is what happens when you have even versus odd exponents. Okay. So let's say I have negative 4 raised to 2. Okay. This means I have negative 4 times negative 4, which would be positive 16. Okay. So this is one of the interesting properties of even exponents. When you have an even exponent on a negative number, you always get a positive answer, no matter what. Okay. However, when you have an odd power on a negative number, this will always give you a negative answer. So in this case, it's negative 64. Okay, this knowledge would come handy many times. Let's see a problem. So here we are doing this one. So quantitative comparison question, I have negative 13 raised to 10 on column A, negative 13 raised to 25 on column B. Okay, so here I have a negative number here raised to an even power to an odd power. I know this quantity would be positive because it's an even power, and this would be negative because it's an odd power. So the answer here is A. Okay, see, you didn't have to pull out a calculator to do this. You just had to look at how the powers, the even and odd powers, will lead to the proper signs. Okay. Alright. Next we'll look at roots. Roots. So roots are actually the inverse of exponents. Okay, so we had said that, let's say we have 4 squared, that's 16. Okay, now one question arises, what should I do to 16 to actually get 4 back? So in this case I take a square root of 16. 4. Another example, let's say 2 cubed. 2 cubed gives me 8, right? Now what should I do to 8 to get back 2? Well, I take a cube root. Okay, so cube root, we put this 3 outside this root sign. On square root there is a 2, but no one writes it, so we never write it. Okay, so root is basically an inverse of a exponent function, right? Now another thing to realize is that both 4 squared will give me 16, as well as negative 4 squared would give me 16 too, right? So when I'm doing root of 16, is this equal to 4 or negative 4? Well, in case of GRE, it's always positive 4, okay? Because this root sign is known as the principal square root. The principal square root. Okay, so on GRE exams, whenever you see a square root of a number, the answer is always the positive, not the negative. Okay, so square root of 25 is 5, not negative 5. Okay, some of these roots you should remember, and the squares actually. So square root of 4 is 2. Square root of 9 is 3. So continue in this fashion. 16 square root is 4. And I think you should do this all the way to square root of at least to square root of 144, which is 12. So this list of perfect squares you should memorize. Okay. Now, well, perfect squares are easy, but what if you have not perfect squares? So let's say I know root 9 is 3, root 16 is 4, but what about root 10? Well, root 10 will give you a decimal, and it will be about 3.16. So this is an example of a not perfect square. Okay, and the way to write roots is as fractions. Roots as fractions. Okay, so if I have, let's say, root of 4, I can actually write it as 4 raised to 1/2. Okay, similarly, if I had root of, let's say, let's take a cube root. Let's say I have a cube root of 8. So then that's I can write it like 8 raised to 1/3. So whatever the root I have, so in this case it was the cube root, then the power is 3. Okay, if I have a 4th root, then the power is 4. The power is 4. Fraction 4, 1/4. Okay. Alright, let's do an example problem now on roots. Okay, we'll do again a quantitative comparison question. So I have square root of x to the 20, and here I have square root of x to the 5 to 2. So column B is easy. This is one of the rules of powers, right? We have 5 x to the 5 to 2. We can just write it as x raised to 10. 5 times 2 is 10. Okay, this one I can remove the square root and put the fraction, right, which is 1/2, and again using the exponent rule, I'll basically multiply 20 times 1/2, which is x to the 10. Okay, so both are x to the 10, so the answer is C. Alright, so to wrap it up, just a few things that would be important to know going forward. So the first is with root property. So let's say if you have square root of a product like this, then you can distribute the square root out to the individual things inside the square root like this. Okay. Similarly, if you have a division going on inside a square root, you can distribute it out to the numerator and the denominator. However, be mindful that if you have a summation or subtraction going on inside the square root, you cannot write it like this. That would be very, very wrong. This is a complete no. Okay. Some other properties, number properties that would be good to remember. So these are actually known as distributive properties. Okay. So first one of these, let's say you have A times B plus C in parentheses. So then this A can be distributed out to the things that are in the parentheses. So A times B plus A times C. Similarly, if you have a fraction like this, so let's say you have B plus C over A, then you can distribute this A, which is like common, which is known as a common denominator, to the things in the numerator. So you can write B over A plus C over A. Okay, and same goes if you have a negative sign. So similar thing. C over A. Okay. Alright. Next, inequalities. So you saw some of these in the problems we did, but just to do a proper introduction of inequalities, you can have a number greater than another number, and the way you write is this with this sign. So this means A is greater than B. Okay. Similarly, you can have A less than B, and you can also have, you can put these bars below the equality sign, and this basically means that A can either be less than B, or it can also be equal to B. Okay, so A is less than or equal to B. Okay. And one last thing before we wrap this section, before we finish this section. Okay. So you know when you have powers, so let's say we have 4 square, 4 cubed, 4 to the 4, as the power increases on a particular number, the value increases, right? So 4 squared would be less than 4 cubed, 4 cubed would be less than 4 to the 4, right? However, this actually, if your number is between 0, let's say x, let's just say x, that the x number is x. If your number is 0, is between 0 and 1, then this actually flips. So let's say you have 0.4. So I have 0.4 squared, I have 0.4 cubed, 0.4, my pen is not working properly, 0.4 to the 4. So in this case, actually 0.4 square is greater than 0.4 cube, which is greater than 0.4 raised to 4. So as the power increases on a number which is between 0 and 1, the number gets smaller and smaller. Okay. All right. And the consequence of this is that if I take a square root of 0.4, actually that's going to be greater than 0.4, right? So another thing to remember. So whenever a number is between 0 and 1, interesting things happen. So take that into account. Let's do a problem about this. So here is our problem. If 0 is less than x, is less than 1. So x is between 0 and 1. Which of the following lists the number in increasing order? Okay. So the three things you have are basically x squared, and root x, right? You're always comparing these three. And the numbers is x has to be between 0 and 1. So one way you can do is basically you can pick x to be, let's say, 0.4. Okay. Find x squared, get a calculator, and find square root of x. Okay. So you would have a very simple calculator on your GRE screen. So something very similar to this. Okay. So x squared, in this case 0.4 squared, so I'll do 0.4 times 0.4 with 0.16. So see how x squared is actually less than, it's less than x. So x squared cannot be the greatest number, so I can take this one out, I can take this out, and x squared is less than x. Okay, and to take root x, I do 0.4 and I take its square root, so I get 0.63. So see how root x is actually the biggest of all these, the 0.63. So in this case, root x is the biggest, so I'll have to pick b. B? Yes, and x squared is the smallest, so b is the correct answer. Okay, so that wraps up this basic arithmetic section. As practice, I would recommend that you do the exercise on page 245 to 247 in the Barron's book. Okay, so this exercise covers all the concepts that we have reviewed in this first lecture. Right? I hope you have a good day. Happy studying.